Right, this is what we're going to use for the rotor. I'm sure anybody in the video world, what this is, a head drum motor. Just machine that edge off. That would be the lower half of the head drum with the bearings in. Drill 3 little holes and countersunk them so they can be mounted to a board nice. That screws on the top, and this is when I've actually drilled that lot, if you can see them, in several places for the magnets. This is one I did for the one that you've seen in my big one. This is just a spare one that I got. So we're just going to actually use 3 of the holes. We're going to use that one, and that one. And we're going to put some, so where my fingers are touching is where the magnets are going. So in a star configuration, if you like, or a triangle. Very important you get them right though. And we're just going to glue some small magnets in there, so I'll get those out and do that. Right, pick my magnets out. Now this is a little compass. I don't know if you can actually see that there. Got my magnets, little Neo ones. And we actually want north facing ones facing outwards on our little wheel. So we need a south attraction. There we go, look. I don't know if you can actually see that or not, but that's a south attraction. So that's telling me that one, because opposites attract. That's telling me that face there is north. So I'm taking that off that one, and we're now going to put that in the end of there that I've pre-drilled. Now just gluing these magnets in I don't think is good enough. I haven't actually glued these yet. I also use a piece of this, which is actually aluminium foil that's used on heating ducting. Sticky back, very strong, and definitely holds magnets in at high speed. And I do recommend you tape them in, even if you glue them with the strongest epoxy resin in the world. I suggest you still put this in as a safety precaution. I'll get on with doing that now. Right, that's our rotor built. I know this has got more holes in it, but I've only actually used 3 of the holes. So now I'll get that assembled up on a board, all complete, screwed together, locking nut on, and we'll get all that done and screwed together for you. Right, that's the piece of board we're going to use to assemble the motor. As you can see, an hole's been drilled in it. That's for the rim of that, so it just sits in the hole nicely, just sticking out the back. Look. So I've actually got to put some little packers on the bottom, but we'll actually screw that in position. Right, that's screwed in position. That's the rotor fitted. The bearings aren't fantastic in it, but they're okay. There's no playing them, a little bit of noise from them, that's all. I should really change them, but this is only a demo. So what we're actually going to do now is we're going to fit this very close to that, as close as we possibly can, so there's not much of an air gap. And we're going to, you can see the dimples, they've got to line up identical to the centre of that. So that's what we're working at now, and we're going to get that fitted. Right, what we've done this time, I wouldn't normally do it like this, just drill 2 6mm holes in those 12mm walls, and we've put 2 dowels in. What we need to do now is find the centre of the actual spindle. So there's the centre. Get roughly where it's going to fit, like so. Make sure the rotor turns. Just quickly mark those up. Then we'll find the centre of those, scrub them in, drill the 2 holes. They do go right through, got a bit of dust in the bottom. Sand them off, just so they look pretty, and you're going to get rid of all the marks. Now I can see the pulse motor and flywheel mounted. I just glued 2 little battens on each side to allow clearance, so that don't touch the bed when it's spin. Now we're going to mount our Bedini circuit and screw it there like that vertically, and then we can make all the connections where they need to be. So that's the next stage. Well, that's it all together. So in other words, that is now screwed from underneath with 3 screws, just to make a complete little unit. And then what we do is we wire from there to the coil. Right, put my first bit of wire on from the start of the motor. So where we put the S run wire for the start now goes to that connection just there, which comes from the positive of the run battery, goes to the start of your windings on your coil. the ones we marked up. Right, first connection on, and obviously the other side of the run coil, which is there, goes to the other end of the circuit as on the diagram. Right, that's both ends of the run coil now connected. I normally don't like to use the trigger coils. I find them I'd rather use the outputs to run something like a bulb or to charge another battery, but for the benefit of the Bedini type circuit we're going to use the run coil. Anybody who wants to duplicate or do what I've done here, you don't have to use this kind of rotor. You can use whatever rotor, a bicycle wheel if you want. That's what the Bedini circuit calls for. Just for the benefit of this circuit and the quickness and neatness, I decided just to stick to this and put it together for you. That coil would run a big wheel, anything you want, so the coil would remain the same. It's just this bit you'd change. Right, you can see that, all the 4 wires connected up. Start of the coils, ends of the coils. So this one here on this side is the trigger coil, and this side is the run coil. That's the start of your windings of the run coil, the end where you finished on your run coil, and same again, start of your trigger coil, end of your trigger coil. Right, now we're just going to put, instead of connecting the batteries right up at the top here, we're just going to put a couple of wires up to the top now, so it'll be charged battery on that one, run battery. Right, so the motor all set up. What I've got to do now is test it to see if it runs. Oh, there she is, running away. Do a bit of a twiddling. Obviously it does make a difference. Slows it down, speeds it up. That's it anyway. Slows it down one direction, speeds it up in the other direction. And its voltage is, that's the input voltage, so the battery's reasonably charged. And that's the output voltage, so it virtually matches. A little bit lower. I suppose I ought to put a dead battery on it first, but I ain't got a dead one, so there you go. But I think you'll agree, good little experimenting board. Only built it just to show you a neater way of building these things. The transistor's not getting hot in any way at all, and neither is any other components. If you wanted to put the other little bulb in, the Bedini circuit says, that wire there, just take that wire off and just add it between them two there. Put the low voltage bulb in, but you'll find this thing will just burn out every time when you do that. As you can see with the battery disconnected, the charged battery that is, you can see the little light glowing there. As soon as I put the charged battery on, which I'll connect up now, and you can see it disappears. The only thing I would suggest is to put some fuses in this line here, well, both these lines, but close to the battery as possible. That's it, nobody wants it. Give me 50 quid, you can have it. Only kidding, just a test. But just to show all you chappies out there, there's another way, as I've said, of building them. Any circuit that this applies to, just bang nails in a board, solder to them, literally. This was the next one I was going to have a play with. They call it a window motor. Well, I hope you find those 3 little videos I've done for you of some use. It actually took me 4 hours complete, start to finish, to build that. But the same as I've said, circuitry is what I work with every day. Anyway, again, hope that's useful. Thanks for viewing.